Okay, so I'm out in the garage now looking at the CNC. I got a little bit too excited last night, and so I did the turning of the square stock down to a round dowel type piece of wood without taking any pictures. So we missed that, but you get the idea. The wood has been secured in the headstock and the tailstock. This is just a close-up of the tailstock right now. You can see how it's actually put together. So the steel ball is being held into this coupling nut with a magnet that is in the middle of the coupling nut. And so you can just manually bring that forward. It slides in, nests tightly. You can just check that with a bit of force. And then you just bring this up to jam it properly. And everything's fine. Okay. Now this fitting in the wood at this end is just a T-nut. And so the T-nut, it works very well. All I did was drill into the wood with a hole for the shaft. I pounded the T-nut flat, and that makes a very nice seat for the ball bearing to sit in. Now these T-nuts are nice because they're steel, they're very hard. The trouble is that these are just stamped out of some kind of a steel, and although this boundary here, this shoulder, is fairly smooth, it isn't perfectly round, and when you put a ball onto there you can feel it click back and forth a little bit as it goes from one edge to the other. It's just slightly not imperfect. So I took one of these, or some of these T-nuts, and I put them on a lathe, a metal lathe, and I just put a round on the inside there to give it a nice seat for the ball bearing. And when you do that, everything rides very smoothly. It's not perfectly flat, and so there's a bit of rubbing that has to take place to take that off. But nonetheless, you put the ball in there, it locks up nicely, and just a drop of oil makes that slide very, very nicely, and it's fairly quiet as well. Now, the actual rounding was very simple. I just turned the square stock here and brought the router back and forth doing passes, and I found that I could easily do half a millimeter deep cuts at about 300 to 500 RPM, and it seemed to work very well. I was using the side of the cutter because it seemed to me that would be the less sensitive to the impact of the corners as they came around. And so that way that they're not hitting square onto the router tool, they're more coming into the side. And so I just brought the tool here and went up and down until it came to the shape I wanted. And at the end of the day, this was very smooth. It could smooth out a little bit with sandpaper, but there's no evidence of any roughness on that to my hand as we go. This end is the coupling nut with the nails, as I showed before, and that works very well. One of the things that I discovered, though, last night was a bit of a disappointment, and that was that in my belting here, although the belt fits very nicely on this pulley, it seems to have a bit of looseness on the stepper pulley. And so I can take this back and forth. I'm just turning the wood here, back and forth, and I can quite often feel a little of a click, and you can see the big pulley turning, but the stepper pulley is not. And it's as if the teeth on the small gear are slightly too large, and they allow the belt to slip a little bit on there. So I'm going to have to get back to the manufacturer about that and see if this is defective, or maybe change the belt design. There are other designs where instead of having square cogs here, they're square-ish, they've got rounded bottoms that don't give any room for slop, and I may go into that. Some of the 3D printer people prefer the round bottom teeth on the belt. They're called GT2s and GT3s because they feel that they don't slip as much, but I'll have to see whether there's a manufacturing defect on this or not. So that's going to prevent me from using this as a normal fourth axis for a while, but we can still use it as the lathe. Okay, so it's time to put the rubber to the road now and see how this whole thing works. I'm going to start off with getting the rotation axis going. I'm going to start that off fairly slowly. We can always speed it up mid-run without any problems, because the speed of the rotation is not coupled to the speed of the motor or the X motion, so you can adjust those independently as you're going through, one with Mach 3, the other with the control program for the spinning axis. So I'm going to get this going now to a rotation speed of about 150 rotations per minute. Now I'm switching over to Mach. I've already loaded up the program, and I'm going to run. CNC part of the program just ended, and took a final pass to finish it off. So now let's see what this whole thing looks like with the motor stopped. Okay, it's got a very rough finish on it here. Don't know if that comes out clearly in the pictures. Much rougher than I was hoping for. So what I'm going to try and do now, just to see what happens, is to sand this out. It's got the right shape. There's nice sharp edges in the middle here, but it's much rougher than I was hoping for. Okay, so I'm going to sand it out. So here it is after the sanding. It's nice and smooth. You can still see a fair bit of checking on the surface, and I'm not sure if that's the wood, the speeds, or what exactly that is. I'll get into that a little bit later. But it seems to have turned reasonably well, and now it just may be a matter of setting the feeds and speeds better. Okay, so this is the final shots that I just wanted to show what the turned product looked like. As I mentioned before, the surface finish isn't as good as I was hoping for, but I think that's mostly to do with the wood. When I looked at the sawdust that had been taken off the material, it was more granular than I was used to, so I think this is an issue of the wood itself. Things I'd like to show you though, first of all, in the upper corner here, this is the shot from a website that I took the idea from for making the gavel. It's a site called turnedtreasures.com, one word, Turned Treasures, and he uses this as a teaching example of how to use the lathe for various projects. In this particular case, I did not put the inset semicircles here. That'll be on the final product, but the overall idea is very similar. You can see in the profile here that you get a very nice transition from the round section into the barrel. It seems to work fairly well. The other thing that's interesting is that I measured the thickness of the post here and the post at the bottom, and they were within about 3 or 4 thousandths of each other. And what that means is that the rotation axis of the wood was essentially parallel to the transition plane of the CNC gantry, which means that again that if they had been very different, that would mean there was a significant slope between the left and the right part of the rotating stock. There isn't, so I think that this approach to aligning the whole thing is working well. It's about 2.5 inches then between the center rotation axis and my tabletop. So the next step will be to improve the quality of the wood to see if we can get something better and to put a little bit more features in here. The final one, of course, will have to have a hole bored here in order to accommodate the handle coming in, and that will be using different techniques within Mach 3. And I'll post that whenever that project's done. Okay, thanks for watching.